Now I want to discuss the subject of mass and weight. What is mass and weight? The mass of a body makes it resist changes in motion. That's what it does, mass of a body. So what is mass? Well, it is the amount of matter in an object, and it's measured in kilograms. That is the amount of matter in an object. Now, the greater the mass of an object, the greater its resistance is to change in velocity. It's harder to push something that's got a heavy mass, and obviously this is called inertia. Now, it's important to realise that the mass of an object doesn't change if the strength of the gravitational field changes. However, its weight does. So this is where I want to clarify the difference between mass and weight. Mass is the amount of matter you have, and it's measured in kilograms. Mass. So I've got a mass of 65 kilograms. Honestly, it's 65 kilograms. That's my mass. Now, on Earth, I've got a mass of 65 kilograms. And on Pluto or any other planet, I will still have the same mass, 65 kilograms. That does not change. Weight is the force of gravity on that mass. Do you understand? It's the force of gravity on that mass, the gravity. So what is gravity? Well, the gravity, denoted G, refers to the acceleration that the Earth imparts to objects on or near its surface. Now, in SI units, this acceleration that's going to give due to this gravity is measured in meters per second squared or in newtons per kilogram. That's what gravity is measured in. And it's got an approximate value of 9.81, which means that on Earth, ignoring the effects of air resistance, the speed of an object falling freely near the Earth's surface will increase by about 9.81 meters per second squared. This quantity is known as generally as little g. That's gravity. So, let's look at this. What is the formula to determine the weight of a body? So the weight of a body is the force of gravity on that body, but what's the formula? Well, this is it here. W equals mg. Weight in newtons equals mass in kilograms, and g is force due to gravity, which is kilograms newtons. And that comes out giving us a weight of newtons. For example, what's the weight of an ant weighing 1 gram on Earth? We'll put these in the formula. It comes out at 0.00981 newtons on an ant. Let's do another example. What's the weight of a car with a mass of 100 kilograms on the moon? On the moon. Now, the force due to gravity on the moon is 1.6 kilograms per newton. Now you put these in the formula. The weight of a car, that car on the moon, is 160 newtons. Do you understand it? It's based on where it is and what the gravitational pull is. Let's do another example. What is the weight of a television weighing 10 kilograms on the moon? Well, the force due to gravity on the moon is 1.6 kilograms per newton. Put these in, that television will express a weight of 16 newtons. So do you understand the difference between mass and weight? Mass is constant and weight is the force acting on that mass, and it depends on the gravitational forces. Now, the force due to gravity on Earth is 9.81 kilograms per newton, and on the moon it's 1.6 kilograms per newton. That's why if you were on the moon, a man can easily jump on the moon, because in effect their weight has been reduced by 84%. That's why if you go on the moon they can jump so far. Now, if you think about it, what do scales measure? Do they measure mass or weight? Well, they must measure weight, not mass, because they're compressed. When you stand on it, it compresses it down. Your weight forces the scales down. So really, you could argue that scales should measure weight and it should be coming out in newtons, but it doesn't. It comes out in kilograms. Well, all the scales do, is it converts it back. Whatever your force is on the scales, force, because that's the weight, and it will convert it back to kilograms. Because if people stood on there and it says you weigh 1,000 newtons, what would people say? Well, it's 1,000 newtons. What does that mean? That's why scales actually do measure weight. They measure the force. They don't measure mass, but they should really come out in newtons, not in kilograms, but they just turn it back. That's all they do.